Hi everyone, hope you are doing great. Welcome back to another video in our Python for test automation series. In our last session, we explored the fundamentals of object-oriented programming, including classes, objects, and constructors. In today's session, we will be discussing some of the core pillars of object-oriented design that includes inheritance, multiple inheritance, superclass, polymorphism, and encapsulation. Let's get started. Let's understand what is inheritance. Inheritance allows any class to inherit the properties and behaviors of another class. In a real world, it is like a parent and child relationship where the child inherits certain characteristics from the parent. Let us understand inheritance with the help of an example. Let us try to define three classes like class animal. I will not put any content for a time being. I put it as pass. Then another class as dog, again pass. Another class as bird, and then I can put as a pass. Okay, so here we are trying to make animal as a parent class and dog and bird as a child class, so that the dog and bird can inherit certain properties from animal. Okay, so basically animal can have a name as a property. Let us go and define a name like using a constructor hyphen init self, and we can also pass another parameter called as name. Then we can initialize self dot name equals to name, and then we can have certain behaviors for the animals, like animals can eat, so we can have define eat method, and we can write like this animal by name is eating. Similarly, we can have another method called sleep, animal sleeps, and then we can write another print statement like given animal is sleeping. Okay, now in order for these classes dog and bird to inherit the animal class, then you will have to pass the animal as an parameter, animal class as an parameter to the child class. Here the animal class is called as a parent class or a base class, and dog and bird are the child classes or the derived classes from the animal. In order to show that dog and bird are derived from animal class, you will have to pass animal as a parameter here, right? Parameter here, and dog can have their own the functionalities, like dog can basically bark. We can give a function as bark, and we can say that the dog is barking. Similarly, bird can fly, so we can have a method called fly. Then we can say birds are flying. Right, perfect. Our code is ready. What we have done, we have created a class called as an base class, which is an animal class, which has a property called name, and it has two basic functions, like it can eat and it can sleep. Okay, then we have derived the dog and bird class from the animal class, which can take a base class as a parameter. Then it can has its own the functionalities, like dog can bark and the bird can fly. So in order to use these classes, then we will have to create an object. Okay, so this is what we understood from our last class on object oriented programming. Let us go and create the instance of this class that is called as an object. We can and see here we have to pass the parameter, right? Since the animal class takes name as a parameter, I can pass a parameter as the name as Buddy. Okay, I have the object now. Using this object, now I can call the functions. Let us see what are the function it exposes. You can see by default we have eat and sleep function, which is coming from the base class. Okay, so let us try to use this. Then dog dot, I can call it as sleep. Then dog has its own implementation, its own function called as dog dot bark. This is for the dog. Similarly for the bird, we can have BIRD, bird called bird. I have to pass a name as Tweety is my bird's name. Then my bird can fly. Then my bird can sleep. So my bird can eat as well. Okay, so now let us go and execute this program and see how it works. If you see here, the Buddy is my dog. It is eating, Buddy is sleeping, Buddy is barking. Then my bird Tweety is flying, Tweety is eating, and Tweety is sleeping. The another benefit that you can get from inheritance is an extensibility. So in a base class you have defined certain functionalities, and in the child class you can extend these functionalities. You can add extra functionalities. For example, in the base class we have added the functionality like eat and sleep, and in the dog class we have added additional functionality called bark, and in the bird class we have added additional functionality called fly. This increases the extensibility factor as well. So these are the additional benefits that we can get from using an inheritance in your programming. Now let us try to understand the benefits of inheritance, why one needs to use inheritance in his programming, right? So one of the core benefits that we get is the code reusability, write once and reuse everywhere. Okay, that we have already seen. In an base class animal, we have written certain functionalities, and these functionalities are inherited to the dog and bird, and we have reused it. Okay, that is one of the core benefits of using inheritance. The second one is the maintainability, right? For example, in future there is some enhancements that is going to happen in a base class, that then you will have to do the changes only in the base class. You need not have to worry about the classes that derived these base classes. Okay, that improves the structure of your code, the readability, and the maintainability as well. Multiple inheritance is a similar concept wherein a given class is allowed to inherit from one or more parent classes. Let us try to understand this. In this example, I will add two classes like class prey. I will give it as pass. Then I will add class as predator. Then I will add it pass. Then I will add few derived classes or a child classes as class as rabbit. Rabbit can only be the prey. pass, then I will add class as hawk. Hawk is a predator, right? So it's a predator. Then I can add another class called as a fish. Fish can be a prey. Small fishes are prey, but big fishes are predators. Now let's add some functionalities to prey and predator classes, like the prey is always running away. It tried to protect itself. So we can add a method called run away, whereas the predators are always ready for hunting. Okay. So here I am not considering any of the properties. In order to print, I am taking the class name itself, right? Class hyphen hyphen name. Okay. This is a built-in function, class hyphen hyphen name. So I'll be using this property, built-in property, in order to make the printing. Okay. Now let us go and create the objects for this in order to call. So let us create an object as rab equals to rabbit, right? Now what can rabbit do? Let us search. Can rabbit hunt? No. If you see, rabbit cannot hunt. Rabbit can only run away. Rabbit cannot inherit the properties of predator. It can only inherit the properties of prey. If I try to do rab dot hunt, it will give me an error. Okay, let us try to execute this. So it says that the rabbit object has no attribute called hunt. Okay, this is because the rabbit is not inheriting the properties of predators. It is only inheriting the properties and the behaviors of the class prey. Okay. Similarly, for example, let us try to do with fish here. Fish equals to fish. Then I have to take this object and see what are the methods that are available for fish. Fish can run away, small fishes can run away, and the big fishes can hunt, right? So this is dot hunt. So let us try to execute this. You see, fish, the class, because the name, what here while printing, we are taking a property as a class name. The class name here is a fish, right? That's why it is coming as a fish is running away, fish is hunting. So fish is inheriting the properties from the two parent classes like prey and the predators. This is what we call as multiple inheritance, which allows a given class to inherit from more than one parent class. In the area of inheritance, Python uses a function called as a super function. This function is used to call a method from a parent class. So the derived classes or a child classes can use a method called super to call a method from the parent class. To understand the super function, I will be using a same example that I have used in inheritance. That is, I have the three classes as an animal, dog and bird, where animal class is a parent and dog and bird are the classes which are inherited from the base class. I will modify the base class here. Rather than calling the two functions, I will have one function called as define makes sound, then I will take it from here and I can put it as this animal make sound. Okay, and for the dog class I will add one more variable or a property as a breed. So in order to define that, I will be basically using a constructor, making use of a constructor for the initialization, and I will take it as a breed, then inside which I will do self dot breed equals to breed. So I have a new property called as breed, and I will be assigning this inside the constructor, right? So if you see, my parent class also has an constructor where we will be initializing the name of an animal. Okay, so I can also do what I can also do is I can also add another parameter to the dog constructor as a name, and then I can invoke the constructor of my parent class using the function called as a super function, right? The super, then I will have to call a constructor as an init, and that takes a one parameter which is a name. I can just pass this parameter. Okay, so what I am doing, I am initializing a name which is a property of my parent class. I can do so by calling the constructor of my parent class inside a child class using a function called a super. Okay, similarly what I can do is I can also do the similar thing for my bird. I can add another property called as a color, and I can do it as init, and I will pass one parameter as color, and then I can do self dot color equals to color. Okay, similarly I can also invoke a name, and but I have to pass a name as a parameter here. Okay, this is how basically we can invoke our properties, right? Invoke a property of the properties of the parent class. Okay, so similarly I can also call the method which is part of the parent class using the superclass. Okay, so let us try to call this using the superclass, and that is inside the method of my derived class. Okay, before saying that the dog is barking, then I can say that super dot make sound, and similarly here also I can say super make sound, right? So this is I am calling the method of the parent class from the child class using a method called super. Okay, now I think these are all not relevant now, so I can have only one method called as, yeah, so here also instead of this I can write it as okay, and I will call this function, and here you have to pass the two parameters. So one is the name of the dog, and second second is a breed, right? Okay. The breed I can make it as German Shepherd. Okay, for a short form I can make it as German. Here I can make it Tweety is green actually. Okay, now let us try to execute this. You see, Buddy makes a sound, Buddy is barking, Tweety makes a sound, Tweety is flying. So we are basically invoking the method of the parent class using a function called super. Okay, super is basically used to call a method from a parent class. Okay, what is the advantage that super brings? It ensures the method resolution order, okay, is respected, especially in case of the multiple inheritance. It also avoids redundant code by allowing the subclasses to reuse the logic of the parent class. These are the advantages that we can get by using the super function. Another important concept in case of object-oriented programming is polymorphism. Polymorphism comes from the Greek word poly meaning many and morph meaning form. In programming, polymorphism refers to the ability of the function or a method to behave differently based on the object that calls it. In programming, polymorphism refers to the ability of the function or a method to behave differently based on the object that calls it. Let us try to understand the concept of polymorphism with the help of an example. Let us consider a class called as shape. So class shape. So I will just add a pass. Then each specific shapes. So we can have the different types of shapes like square, circle or a triangle can calculate its area differently. So the circle needs radius to calculate its area, square needs length of its side and triangle needs a base and height. Even though each shape has a method called calculate area, the actual implementation of the method differs depending on the type of the shape. This is called as polymorphism, one method name and many different behaviors. So I can make a shape as a base class. Then I can have the child classes like circle, and circle is derived from shape, and then I will add it as a pass here. Then I can have square, again derived from shape, again pass, class triangle, again shape, again pass. So I have the child classes which are derived from a base class called as shape, circle, square and triangle. Now my idea is to calculate the area. So I will have a method called calculate area, then self, then pass, so what I told, for a circle we need a parameter as a radius to calculate the area. So I will have to define and constructor in it, and I can give radius, then self dot radius equals to radius. Okay, similarly I can have for a square, it is like side, length of a side, so I will take it as a side only. Then I have a side, I have a side. Okay, and similarly for a triangle we need length of a side, and we need height as well. Okay, so I'll give it that ht, then length equal to length and height equal to height. Now we can calculate the area as area equal to, here I have to take it as length height, it is 0.5 0.5 times of length into height, length into height, that is the area of a triangle. Now our calculate area function is ready for each of these three shapes. So I basically forgot to implement the return statement here. Return area. Okay, now basically our calculate area function is ready for triangle, square and then circle. Okay, but we are missing a key implementation in Python to implement the polymorphism. So in case of Python, polymorphism can be implemented using an abstract method. An abstract method is a method that is declared in the base class but does not have any implementation. So for example, calculate area we have defined in the base class, but it does not carry any implementation. Actually, it is implemented inside the respective child classes and each has its own logic. Okay, so the abstract method basically forces the derived classes to implement this method, ensuring the consistent behavior across different classes, yet allowing each classes to define its own logic. So in case of Python, the abstract method can be implemented by the import statement. Here we are trying to import ABC and abstract method from ABC. Okay, and then you will have to take abstract method as a decorator and put it above the above the method in the base class. Okay, by doing so, we will be implementing calculate area as an abstract method. In the base class it does not have any implementation, but in the child class it has an implementation pertaining to the having its own logic. Okay, circle has a different logic to calculate the area compared to square and triangle. Now let us go and create the object for each of these classes. So I can put it as C equals to circle and I can pass the radius as 5. Then similarly I can have square equal to square, I can pass the side as 4. Then I have a triangle, T equals to, let us copy here and put it, it needs two parameters. The length I will give 4 and height I will give it as 6. Okay, now using this object, let us try to call, or we can basically print the area. So I will use the format print and then I will have to use C dot, I have to call calculate area, but I will do it like something like this, and I can put it as area of circle is something like that. I will copy this and put it for other two. Only thing I need to change here, it is S and it is T here, and instead of area of circle it should be square. So and here it is triangle. I think we are ready. Let us go and execute this. You see, so I am doing something wrong here. So I am just calling the method without passing the parenthesis, right? This is wrong. In such case, it returns me the object itself, right? Yeah, it's also one of the good learning. So see, it basically give an object for this method, right? Yeah, it's written that. Okay, so actual way of calling is with parenthesis. I missed that, sorry. Yeah, now the implementation is ready. Calculation is done. Area of circle is 78.53, square it is 16, and for triangle it is 12.0. So this is how we can implement the polymorphism in case of Python and using the abstract method. Now let us try to understand another important concept of object-oriented programming by name encapsulation. Encapsulation is basically a practice of hiding the internal details of how an object works and only exposing what is necessary for the outside world. Okay, so you can think of encapsulation as just as a capsule. So you really, as an user, you really don't know what medicine is inside, right? So what you do, you take a capsule and the capsule does it work. So it is made for curing some kind of a disease, so it does that work, right? But as an user, you really don't know what the capsule contain inside. Okay, it's a similar concept in case of object oriented programming. See, the encapsulation basically helps you to protect the internal state of an object from an unintended or an harmful changes. In case of object oriented programming, encapsulations can be achieved by defining a class attribute or an class the class member, right, as an private or protected. If you see, all my examples are there and these are my attributes, right? So radius, the side, here I have a length and height, all these are declared as a public. Okay, so what we can do here, so we can directly go from here after you have an object, right? So I can basically print, right? I can basically print c dot the radius. I'm able to access the member or an attribute of a class outside, okay, outside of my class. Okay, so okay, this can be done when the attribute is public, but encapsulation does not allow this. Encapsulation always tells about protecting your class members. So this can be achieved by basically treating these attributes or the members of your class as a private or protected. Okay, this can be achieved by using underscore or a double underscore. So double underscore basically tells you that it is completely private, so you cannot access it outside of the class. Okay, let us try to understand the encapsulation with the help of an example. Let us try to implement an bank account class as a bank account, and this will have an constructor, and inside which I will be initializing a balance. If you see here, I am using underscore underscore, that indicates that the attribute balance is a private. Now I am going to implement the two functions. One is called as deposit. Deposit is basically, so what I am doing is I am increasing my balance, that is my balance equal to self balance plus the amount I am going to add. Okay, And if you want to get the balance, then you can have another function like get balance. That balance basically will retrieve the balance amount. Let us try to implement another method by name withdraw. So you are trying to withdraw the amount, and before withdrawing you'll have to get the available balance, right? So I will get available balance as, so I can use this method self dot get balance, and if the available balance is less than the amount that is requested, then I will have to throw an exception. So I have to rise, I can give it as a value error, then I have to pass the message telling that requested amount is higher, sorry, requested amount is, I can make a small letter, higher than the available balance. So I have to make it as available balance. If the available balance is greater than the amount to be withdrawn, then I can make it as self balance equals to the self balance minus the amount, right? Yeah, it should work. Now let us create an object. See, bank account equals to bank account. So let us check the initial balance. Print with the format specifier. I have to call ba dot get balance as a function. I can put it as balance is, but this should go inside the parenthesis. I will again, I'll call that, but before that I have to add some amount. So I have to deposit an amount of €100. Now I will calculate the balance. Again I will take this, then I will make it as va dot withdrawal, then I will take it as €50. I will again calculate. Again now I will try to calculate the withdrawal. I will try to do the withdrawal. This time it is €150, and I will try to get a balance. First let us execute this program just to check that if it is working or not. Yes, it has given a value error because the value requested is higher than the amount, okay, that is being requested. I think there is something that is wrong. Okay, here it is selling, sorry, I was looking at the different message. The actual message is this one: required amount is higher than 50. Whatever available amount was 50, right? And then you're trying to withdraw 150, which is not allowed. So the logic is correct, but now we'll have to show what encapsulation means, right? So now let us try to, let us remove this line that causes an error. Now using the object, let us try to get this balance, access this balance. Okay, let us see what it gives. Yeah, it has given us an error telling that the attributed object has no attribute called balance. So the balance is not visible outside of the class. It is contained, it is confined, or inside it is encapsulated within the class. So you cannot access any private member or unprotected member outside of the class. Okay, that is basically about encapsulation that helps in the it increases the security of your implementation. It basically about all about the protection. That brings us to the end of this session. In this video, we explored some of the most important concepts of object-oriented programming that includes inheritance, multiple inheritance, the superclass function, polymorphism, and encapsulation. I hope you enjoyed learning with me. If you find this video helpful, please consider liking, sharing, and subscribing. Thank you for watching.